All right, so we have, suppose a sample of size n equals 14, read carefully, suppose a sample of size n equals 14 is taken from a normally distributed population with mu equal 142, sigma equal 10.3. A sample of size n equal 14 is taken from a normally distributed population with mu equal 142 and sigma equal 10.3. Okay, question number one. Has the sufficiently large requirement been met? And why? More to the point, why? Have we met the sufficiently large requirement for the central limit theorem to work? Anytime you take a sample from a population, anytime we will, going forward from now till the end of the semester, whenever that is, from now until the end of this semester for the work we're going to be doing, anytime you take a sample from a population and you want to use the normal curve, you must check to see if the sufficiently large requirement is met. It is going to be met, but you should be aware of that. Have we met the sufficiently large requirement? Well, what are the two ways to meet it? One way is if the sample size is 30 or more. We have not met the 30 or more condition, so that one's right out. But what's the other requirement, possibility? Yes, if the original population is known to be normally distributed. So because we are given the population is normally distributed, that guarantees that n equal 14 has met the sufficiently large requirement. And if we have met the sufficiently large requirement, and only if we have met the sufficiently large requirement, then we get to use the normal curve techniques that we've been discussing. But the new piece is, this is still the z-scale. This is now the x-bar scale. What goes on this bottom scale is not individual raw data values. What goes on this bottom scale are the sample means. The sample means taken from this population for samples of size 14. Now, anytime using the normal curve, we need to know where is it centered. Well, the normal curve is centered at, in this case, 142, because the central limit theorem says that the sample means, the x-bars, are centered at the same place the raw data is centered. So this is centered at mu equal 142. And the standard deviation is given 10.3. And so now the question is, what are we being asked to find in our question number 2? What is the probability? Find the probability. Find the probability that the mean of the sample. So this is read it and write it. Find the probability. So find the probability that the mean of the sample, x bar is the sample mean. This is not x, it's x bar, because this is the mean of the sample. Make sure you delineate between x and x bar. This is the mean. And now it's just read it and write it. Less than 138. So we need to find the probability that x bar is less than 138. So we place 138 in the appropriate spot on this axis. This is 142. 138 is over here somewhere. We want to find the probability of being less than, so our squiggly line in the technical jargon we're using goes to the left. The shaded region that we're looking for, the shaded region we desire, should always match the squiggly line. These should always match. The arrow always goes to the left no matter what. So in this particular case, the arrow matches the shade, which everything matches up. So as soon as we find the value on this arrow, we're finished. So now the next piece is, how do we translate from the x-bar scale to the z-scale? Well, that's our new, I'm going to have to erase and get some space here. That's our new formula. Z is equal to x bar minus mu. The denominator is now different. Sigma over the square root of n. And let's substitute and simplify. X bar is given where the x bar is 138. minus sigma is given, that's 142, over sigma is given, I'm sorry, mu is given, 142, sigma is given, 10.3, over the square root of the original standard sample size was 14, and compute. Now, this can be a little bit dicey if you're not used to this. If you are good at using parentheses with your calculator, what you ought to do is put parentheses around the numerator and parentheses around the denominator. If you don't, the order of operations, which are in the machine, will get messed up if you don't account for that. And so one option is to put parentheses around those, the numerator, parentheses around the denominator, and then hit equals. Another option is to compute the numerator, hit equals, write it down, lay it off to the side, clear your calculator, compute denominator, hit equals, lay it off to the side, and then go back and take numerator divide by denominator. If you do that, you may accumulate some round off error. So you should be able to make your machine get the value I'm going to be getting. So I'm going to compute parenthesis 138 minus 142, close parenthesis, divide by, open parenthesis, 10.3, divide by the square root. Now, on my calculator, on many calculators, when you hit the square root key, it opens a parenthesis for you, so you need to remember to close it twice. This is my 14, close, close. And so I have, again, rounding to 2 decimal values, I have negative 1 point, try that again, negative 1.47. I've actually rounded up. I had negative 1.467, and that rounds up to negative 1.47. So make sure that you can make your machine say that number or something that is very close to it. If you round differently in a different location than I did, you might get negative 1.48. You might get negative 1.46. But something approximately that. If you get 3.15 or if you get 72, you screwed that up, go fix it. But something approximately this, and that goes here, negative 1.47. And then this is the same as always, the table value, right? We need table value. And I have negative 1.4. I'm going to enter from the right-hand side of the table, since this is so expertly designed. Negative 1.47, I have 0.0708. The number from the table always goes on the line. And since that is what we're looking for, that's our final result, is 0.0708. And so what we'll do next is just run through several examples using this formula and see if we can get used to working with that.